what we need to do is we need to handle this thing, since we shouldn't be using this equal operator, and we should just copy the element in this memory. So what I think what we should do is we should reproduce the error here, and I think I could have here, if I remove this, then when I just execute this program, it should okay. Also I need to handle push match. I need to handle this. Okay, so I need to build, then run. What? How on earth is this working? Anywho, okay, should I clean? And it works, which is suspicious. Yeah, I know why. Okay, I know exactly why. Yeah, because of this. If I convert it to this type, then it should crash. Okay, here is a crash. So what we need to do is we need to fix this error here, and this error is exactly happens in stack array. And also let's check stack list, but I think that the stack list is fine. It is, so we should handle on only stack array. So what we need to do is we need to just call the constructor upon this memory. So what we'll do is we will just get the data pointer, increment it with the count of the elements, then call the constructor. And this, ladies and gentlemen, should work, and it should work in each. What happened now? Yeah, okay, and this should work in each case this way. Of course, what we need to do here is just call the copy constructor, then here we should call the move constructor, and this should compile and work. Okay, it compiles, but shall it work? Yes, it works. Okay, it works in debug mode, so let's check release mode. Okay, release. Oh no, not the scratch but the unit tests, and it works also. So let's push this fix stack array move like what, of crash. Okay, get status. We should be able to push this edit, and we should go to our other project. Then we could like go to the dependencies and pull the latest master. Yeah, this is the latest master. Then we should go back and build, and we shouldn't encounter the crash. And we didn't encounter the crash. Okay, so we should go there and return the moves. Steady move. Since the compiler is not like it is not smart enough to detect that we need moves in these places, so we help it a little bit, and in return we gain performance. That's fantastic. Let's check the release build. Of course this should have like a like some allocator here. If we have some like arena allocator or things like that, the memory allocation and the doubly linked list should work just fine, or it works fine, but it should work faster than this. But what we'll do right now is we will just clean this like mess of the code, and we should like do it. I don't know, should we like do a file for the instructions and the execution nodes and the cartridges, or we put everything in one file? If we put everything in one file, then it should be like easier to compile, but I do not know. If this was a CBB file, then I'm pretty sure it would be faster, but this is a header file, and it will be included in like many areas, so it is like, I think it is better to slice it into smaller pieces. Then when like someone needs exactly one thing, he shouldn't like get other parts of this file. Like, for example, if someone needs the instruction sets, he could include just the instructions headers. He shouldn't bother with the compilation or the virtual machine. So what I need to do is slice this file into 3 different files. First one is regex underscore instructions. Then we shall make this file now. Touch oct include oct. What is exactly regex instruction.h. Okay. Now we shall open this file, drag mount, by the way, oct is the short term for Open Compiler Tools. Yeah. So this is a cool way to do a heterogeneous containers, not exactly heterogeneous, but we a cool way to do some polymorphism stuff. We do not need to do an abstract bytecode and stuff like this. We only need to do a union of the data and the instruction, and a bytecode could be an instruction or a constant. In this case we should, in the case of instruction we should access this instruction, in the case of constant we should access this data. Okay, so a bytecode could be initialized with data. In this case the type is constant and the data is of course equal to the data. Okay, and it also could be initialized with instructions. In this case the type is instruction and the instruction is instruction. Okay, So what is the type of this like program? A program, we call it cartridge, or shall we call it a program? It is a regex program that is that contains a sequence of bytecode. I do not know. Should we call it cartridge? I like the word cartridge because it reminds me when I was a child and I used to play like some replicas of the NES, and we had these cartridges, and each game was on a separate cartridge, and we could like swap this cartridge around and load another games, and a game is a program, of course, and we could load different games by swapping these cartridges. So I like to visualize the idea of a regex program as these cartridges, and we could swap these cartridges of regex code or regex bytecode around and load other programs and stuff like this. I like the word cartridge, but it is like, I think it is not obvious like to anybody else when you see regex, like when you see this regex cartridge, you do not know exactly what this like thing is unless you have a look at the underlying type. In this case you would see it is just a sequence of bytecode. So I do not know, maybe I would call it a program, and this regex program is just an alias for let's just say this program is for now it will be a dynamic array of bytecode of type T, and we shall include the dynamic array container. Okay, now what we need to do is we need to be able to print this program for debugging purposes. Okay, so there is two equal and important, there is two stages in printing this program. We should go loop over this program and print each bytecode. So there will be two operator overloading here. Okay, what we need to do is include the output stream, then we should okay, this is the char type and this is the T bytecode type, and we inline static output this operator, we should like get this out operator, then we should get this bytecode. Why is this? Yeah, why? I do not know. Maybe it is this IntelliSense stuff is broken. Anyhow, what we need to do is we need to switch over this bytecode, and exactly over this bytecode type. Like you see here, if we used the traditional polymorphism, we could not be able to do this trick. We we'd do it this way, like auto instruction byte, for example, and we could like dynamic cast the thing to it and check if it is a null pointer, and then we would use it. But here, since we have the type, we could switch over this type, and in case it is like an instruction, then we do something, and in case it is something else, we'll do something else. Okay, byte code of T. Would it matter? I do not know, but I will not risk it. So in case of it is an instruction, we should print that this is an instruction, and we then have to like we could like do this print instruction and like send the bytecode instruction, and this should work. But what we need to do here, I think, is have a namespace that is called details and implement this stuff here. Static void print instructions, and it should be templated over the type of HR std basic outstream of the char, and we could have this instruction, and we will also switch over this instruction, and in case it is a none, we would just do this none. Case it is a match, we should do this match. And in case it is a halt, we should print a halt. And we could do this, we could move the none instruction to the last thing in this switch statement, since it is not likely to happen. And this should be the default instruction. Anyhow, we should call it of the details namespace. Okay, and in case it is like in case it is a constant, we would output constant then we would print like we will print the bytecode data. Okay, this seems to work. We should like test if there is an error, but I do not know why this thing expects a semicolon. I do not know. Really? Yeah. This is T bytecode, and this is also a T bytecode, and this is a T bytecode. Okay. It is not a T. Anyhow, this is, after all, it's just Microsoft stuff, and I do not trust Microsoft exactly to do a good job in like parsing and providing intelligence of C++. Okay, what we need to do now, yeah, I know I forgot to do this stuff. Yeah, I think it was my fault after all. Okay, we now should implement we should do this like utility thing in line static. Okay, we should be able to count the digits of a number. The ceiling of the log 10 of this number, and this should work, but we need to include the CMath, and I think we are good. Okay, so what we will do is that we will we'll calculate the width of the counter details, count digits of our program size or count, and we should have like a counter of some sort. Yeah, I think I should like check the micro benchmark stuff, how I do it. Yeah, we should set W, yeah, std set W, or set width, then we should set the fill to be a 0, I think. Or you know what, I'll not set the fill to be anything at all. Then this should be the eye. Then we could do like something like this, and we could do like, yeah, we could do something like this. Our program of I. This should work just fine. This one-liner, yeah, it should work, but I do not know. Let's try and compile it. Okay, we didn't get anything useful by compiling it, so we will just remove this program, and we shall replace it with the new stuff. Regex instruction, yeah, oct regex instruction.h. Then we could like build it and get all kinds of errors. Okay, yeah, I think we forgot to include the IO manipulations. Okay, like we shall like go to the line 36, and we should like get this program, and this is a program, this is also a program, and we should like remove all these operators for now, and then we should also remove all these operators for now, and I think we should like leave those. Okay, and then we should get this program and rename it to out program, and let's see, should like remove all of this. All we do right now is concatenation operator. Then we here should like get this to there, and I think this execute instruction. I think it works. It is a generic function. I think this should be a program, and then this should be an in program, and this should be an in program also. Okay, it is an in program. Then I think we should compile just fine, but there is some issues. Okay, instruction, I think we have like instruction, I think, yeah. Okay, English is not my native language, so, but of course I know that instruction needed a C there, but yeah, I think at line 106 this should be instructions. Okay, where else should we do stuff like this? Okay, 169, this should be a match. Okay, where else to do this stuff? I think, yeah, T program. I know it is not like, we will replace this like shortly, but we need it to compile to like check our code. $177, this thing, I do not know what to do now. Okay, well, for now we shall like remove this, and what we should do is we could like do this T program ID, then data type, then const. I think this should work, but I do not know exactly. 216, this should be the in program, and this should be the in program. Okay, I think it will compile now. Yeah, the main function, or the benchmark, it should like this program, and this should be let's see what will happen. I think it will be fine since we do not like use the regex namespace, so I think it will be fine. T program instruction, there is, okay, let's go back to the regex, then we should go to 215. This T program isn't exactly what, okay, what we need to do is byte code of T program to be this thing, then it should compile. Okay, but there is no instruction. Of course there is no instruction, there is instruction. Yeah, and it works. Okay, let's run the thing, and it works just fine. Okay, fine. Let's check the release also. Yeah, it works. Okay. Now, what we should do now, since we separated the instruction stuff, then we should not separate the regex compiler and the regex virtual machine. So what we will do is we should make like another file called regex compiler.h, then regex compiler.h, and then we should move this stuff to it. But of course we need to do some stuff. Okay, oct, then in the same namespace that is called regex, we will just like copy and paste these functions there. Okay, and then we will have a namespace called details, and these details should have the operators. Also it should have the compiler state. Then I think it should have like pop operand. I think it should have all of this function, all of these functions. Okay, and there shall be one function to call, and it is a compile function, and I think we should decorate these types with the namespace. Okay, I think we are fine. No, we are not fine. There is some functions to prefix it with the namespace. Also, yeah, I think this should work, but of course I'm not sure. So let's try the compiler. Regex compiler, then we could like do this stuff. Okay, it works. Yeah, it works as expected. That's fine. And I think we only need to like do it, remove all this stuff. For now we have a concat operator, and the compiler state, it has this stuff, and I think we should include the stuff we need, such as stack array, and what else? We should include the regex instructions. What else? we, I think, are fine for now. Yeah, we're fine. We're fine for now. Okay, so we have operators. These are regex operators. And I think it is obvious, so let's remove this comment. There is this compiler state, and it accepts the bytecode stuff, or like, yeah, the tchar, because the program, or yeah, t bytecode sense, it is the type of the bytecode. Also here I think we have a compiler state of this t bytecode, and the program of the t bytecode, and in pop operand we should like get this. If the operand is empty, we return false, and otherwise we get the top operand and move it into A, and then we pop the operand and return true. Okay, and to do an operation concatenation, we should like, what we should do is we get two programs, A and B, and get B first, then A, and I think it works this way. Okay, then we like insert all the elements of B to the back of A, and then we move the A into the operand's stack and return true. Okay, and in case of evaluation, like we need to like get this eval. It is not an operation. No, we'll call it eval. Okay, eval just pops an operator of the state, and then it do it. If it is a concatenation, it does a concatenation. Okay, fine. And then there is push operator, and push operator, we should call it eval operator. And push operator, I think it is fine. It gets the state and the operator to push, and if it is like higher in precedence than the top of the stack, then it evaluates the operators on the top of the stack, and then it pushes this operator. Okay, it is fine, I think. And then there is push match, and I think we should like I think we should leave it like this for now, and we shall do a compilation and see if we broken anything. And I think we did not break anything. Then we should change this to push char, and it gets some like we should change all of this to t bytecode. Okay. Why? Why is this exactly? Because the C could be a constant char. Okay. 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 I see. Okay. Fine. I'll leave it. I'll leave it this way. And I think we do not need this bane anymore. Okay. T input and T output. Yeah. I should go to the instructions and add another instruction, and this instruction is called char, and this char instruction is just a bit different than match. Of course it could be like transformed into a match, and it should be transformed into a match. But I think for now we should leave it as a match. Okay. So now